Here's your warm-up. Please pause and solve. Okay. When I look at this, I see this as a pretty straightforward u-sub problem. I'm going to call u 1 plus 2x, and du is therefore 2 dx, which means I need a 2 here and a 1/2 out front. I'm going to u my limits of integration, so u of 1 is equal to 3, u of 4 is equal to 9. Is that right? So I have 1/2 times the integral from 3 to 9 of u to the 1/2 du. When I bring this up a power, this becomes u to the 3/2, and I have a 2/3 out front. And this is evaluated from 3 to 9. And so I'm left with 1/3 times 9 to the 3/2 minus 3 to the 3/2. And I don't really feel like taking it much further than that, so I think I'm okay with that answer. What we're going to learn about today is not really part of differential equations, but I'm never really sure where else to put it. So we're going to talk about arc length, meaning how do you find the length of a curve? We found the area under a curve, but this is going to teach us how to find how long a curve is. So we're going to develop a formula for determining the arc length of a section of a curve, and we're going to start by approximating that distance using a straight line segment. Okay, so if something is curvy, we could certainly approximate it as a straight line. It's just not going to be very accurate. Okay. And we're going to do that by using the distance formula. So it's going to be the square root of the distance between the x values squared plus the distance between the y values squared. And hopefully you know that this is just a rewrite of the Pythagorean theorem. If you didn't, think about that for a second. And with that in mind, we could, instead of taking a curve and making it one straight line, we can take a curve and think of it as many, many straight lines added together. And if we make them infinitely small and add them together, it will become quite accurate. Okay, so we're thinking in terms of limits and integrals and things like that now. So instead of one straight line, I can think of it as the sum of many straight lines. Okay. And instead of calling it x minus x and y minus y, I can just call it delta x and delta y. Hopefully we're okay so far. We're just adding together the lengths of many small line segments. And I'm going to do some algebraic manipulation here. All I did was, this guy is the same, and all I did here was both multiply and divide by a delta x squared. All right, and I'm allowed to do that because all I did was multiply by 1. And if I factor out a delta x squared and take it out of the square root as a delta x, that leaves me with the square root of 1. I divided by delta x here, and then I divided by delta x here, so it just left me the delta y over delta x, and then this delta x is outside of the square root. But if I make these delta y's and delta x's infinitely small, and I take an infinite number of these segments and add them together, well, this summation stops being a discrete sum and starts being an integral, and all these delta y's and delta x's become dy's and dx's. And we have an integral. So I have the integral from the x value of a, the starting x value, to an x value of b, the ending x value, times the square root of 1 plus dy dx is just f prime of x squared, and I'm integrating with respect to x. This is the formula for the arc length of some function f of x between x equals a and x equals b. So here's an example. I want the arc length of the curve y equals x squared plus 8 on the interval from 1 to 3. So this is going to be the integral from 1 to 3 of the square root of 1 plus, I need to find f prime of x. What is it? 2x squared dx. My hint to you is that these are usually calculator questions, and I want to take this second to review with you how to put these integrals in your calculators, because I know that we were a little bit weak with that at the beginning of the year. So when I exit this slide, it's going to go away, so make sure you have this integral written down. It's the integral from 1 to 3 of the square root of 1 plus 2x squared dx. I'm going to pull up my calculator, and I'm going to go to Math, and I'm going to go all the way down to Fun Integral. And some of you have that fancy type where you can just type in what you need. That's great, but I know some of us don't, so let's review how to do that. I need to take the integral of the function square root of 1 plus parentheses 2x squared, and that's the end of the square root, comma, with respect to x, comma, as x goes from 1, comma, to 3. So yours should look like this. And when I do that, I get that the arc length is 8.268 units. So that means the length of that curve from x equals 1 to x equals 3 is 8.268. These can also apply to functions of y. It really doesn't change that much, okay? So if I have y of x, I use the other one. If I have x of y, I use this one. It's the integral from c to d, where c and d are now y values, of the square root of 1 plus g prime of y squared with respect to y. So for example, if I have the curve x equals the y minus 1 all raised to the 3 halves from x equals 0 to x equals 8, I need to start by taking the derivative of this equation right here. So x prime is going to be 3 halves times y minus 1 to the 1 half, which if I square it, I get 9/4 times y minus 1 to the first power. So this is going to be the integral of the square root of 1 plus x, where'd my 1 go? 1 plus x prime squared, which is 9/4 times y minus 1, dy. And I notice a problem. The limits of integration are given to me as x's, not y's. If I'm integrating with respect to y, these need to be y's. So I need to figure out which y values are going to yield these x values. So I want 0 to equal y minus 1 to the 3 halves, and I need 8 to equal y minus 1 to the 3 halves, and figure out what y values make these statements true. The first one's pretty easy. It's y equals 1. 1 minus 1 is the only thing that's going to give me 0 here. The second one's a little trickier. I don't know that I can do it in my head. I'm going to have to raise both sides to the 2/3 power. And 8 to the 2/3 power, I don't know, the cube root of 8 is 2. 2 squared is 4. So this gives me 4 equals y minus 1. So y is equal to 5. And I can plug that in and double check. 5 minus 1 is 4. The square root of 4 is 2. 2 cubed is 8. So that does work. Now, when I put this in my calculator doesn't care that this is x as a function of y instead of y as a function of x. It truly, truly does not care. So I'm going to put this in the calculator exactly like I put the other one, like it's in terms of x. So I'm going to go to Math and down to Fun Integral, and I'm going to type in my function, which is the square root of 1 plus, I already squared it, it's 9/4 times y minus 1, so this is 9/4 times, and I'm just going to call it x minus 1 because my calculator does not care. I'm going to close the parentheses for the square root, comma. I'm integrating with respect to x. Even though it's really y, I'm going to call it x, comma, as x goes from 1, comma, to 5. And when I do that, I get an answer of 9.073. Hopefully that's what you get as well. Okay, that is it. Your homework tonight, homework assignment number 5, is up here. I also want to give you an optional 9 weeks review assignment, okay? It's from the Fast Track to a 5 book, which you can check out from the Media Center. Okay, they have enough copies of these. This is very much optional. But if you do the entire thing and turn it into me by, let me look at my calendar. By Monday, 10/21, then I will give you a 50 out of 50 test grade, headed into the end of the 9 weeks, okay? So to be clear, this is worth a 50 out of 50 test grade. If you don't do it, it will not hurt you, okay? But you need to turn it in class on Monday, 10/21. So some of you need a little bit of help in your test column, and this will help with that. So it's from the Fast Track to a 5 book. It's page 130 to 136, all of the problems, and page 169 to 173, all of the problems. All right, I'm not going to take it late because I've got to get grades in for the 9 weeks, okay? But if you turn it into me on Monday, 10/21, I will give you a 50 out of 50 test grade. For those of you who either did a really poor job on the summer assignment or never turned in the summer assignment, I will replace your summer assignment grade with this if it helps more than a 50 out of 50 would have. So I will sit down and calculate your grade both ways, with the 50 out of 50 or with replacing your summer assignment grade with a 50 out of 50. And then whichever one helps you more, I'll do that one. If that doesn't make sense to you, email me and I can try and explain that a little bit better. This is optional. If you don't do it, it's not a 0 out of 50. Your grade just doesn't change. Okay, so here's homework number 5, and then this optional assignment. You can check this book out of the Media Center. Okay.